Now I will explain the important derivations. First one, interference in thin film. So question comes in the exam, derive an expression for interference in thin film and also write the conditions of maxima and minima. This question may come for 10 marks. Okay, almost 3 to 4 pages this derivation will take. So we'll continue. I will draw the diagram first. So let us say this is the upper plane glass plate and this is lower plane glass plate. Okay, so upper plane glass plate is this one and this is lower plane glass plate. Between these two glass plate, so this is called as plane glass plate 1, plane glass plate 1, and this is called as plane glass plate 2. Between these two glass plate, a thin film is placed. Maybe soap bubble or oil is placed, having thickness is small t. So this here can be oil or soap bubble can be placed. Soap bubble. Okay. So now what will happen if the light will incident on these two glass plate where inside the glass plate there is a oil or soap bubble is there, denser medium is there. So whenever first time rays will incident here, incident ray, then we draw normals to this. This is the normals. There will be partly reflection of rays and there is a refraction of rays. Okay, it gets refracted. So this will be incident angle I and this will be refracted angle R. Further, once it incident here, the normals are drawn. So from here also there will be a reflection of rays. So reflection takes place within this reflection and this will be here a refraction or transmission away from the normal. Okay, so this is what. Further at this point, which incident, the normals are drawn to this point and rays will be reflected. Okay, and here it will be reflected through multiple reflection from the lower surface, and at this point also therefore it can be drawn normals, and here also the rays can be what, refracted. So in this way there is a multiple reflection. I can go on continuing drawing gram. So this is reflected ray R1, reflected ray R2, and this will be transmitted ray T1, and this is transmitted ray or refracted ray T2. This is incident ray. I will draw the normals to this reflected ray R1. So this is the, from this point the normals are drawn. Okay, so I can give the name here capital M, and this is A, B, this is given C, and point D, point E. Okay, and this I can use N, and this is N dash, it can be given. Okay, and normals are drawn in the transmitted ray also. Similarly, on the CT1 the normals are drawn like this. So this is the complete diagram of interference in thin film. If this angle is R, this will also be R, and then this will also be R. Okay, if this is incident angle, this will also be incident angle I. So these angles are very, very important. Okay, so this is the complete diagram of interference in thin film. Now we'll talk interference in reflected system. That is, after reflection, suppose the light will incident here having the crest and the trough. Okay, after reflection it may come crest and trough, first ray, and second also can be crest and the trough. So when they will superpose each other, the resultant can produce constructive interference plus A plus A. So, or it can be destructive interference it can produce. So that is what we need to find out, the conditions, whether it is constructive bright point or whether it is destructive. Same way in the transmitted also it take place. So here also crest trough, and here also, so they also can produce constructive or destructive, but we are not interested in the transmitted system, we are interested only in the reflected system. Okay, let us continue the derivation, how it can be derived. So here in a reflected system, let us say BR1 and DR2 are the ray are there. So this is BR1 and this one is DR2. Okay, in the reflected system. So optical path difference formula is there. Path BCD inside the film. So this is the film. So film sorry, so these are the film is there, maybe oil or soap bubble. Path BCD inside the film minus path BM in air. Okay, so path BCD, how we write? BCD is this, B to C and C to D. So BC plus CD, and inside the film refractive index is mu, so mu is multiplied with this distance. And here also in air, BM is in air because above the surface, so it is mu times BM, but air mu is equal to 1, so this equation becomes BC plus CD minus BM 1. Now we'll continue the triangle. So let us say triangle BCN as well as DCN. Find out cos R. BCN if I am taking, so cos R will be equal to adjacent upon hypotenuse Cn upon what? BC. And here also if I will take cos R, so Cn upon what? CD. So BC and CD can be calculated. Our target is to calculate these things, BC, CD and BM. So cos R, Cn upon BC, that is equal to Cn upon CD. So BC can be Cn upon cos R, CD will be Cn upon cos R. Continue. What is Cn? So Cn we have taken the thickness of the what? Film. Cn is this. See, this is the Cn. Cn is the thickness of the film we have taken. Okay. So BC is equal to therefore T upon cos R, CD T upon cos R. Therefore BC plus CD, add it, T upon cos R, T upon cos R becomes 2T upon cos R. Now, so we got the VC plus CD, where in this equation we can substitute it in the equation number 1 BC. Now our target is to calculate BM. So using triangle BMD now. So see this diagram, BM and D. Calculate sin I will be equal to opposites upon hypotenuse BM upon BD. BM upon BD. So BD can be written as, therefore you can see BD is BN plus ND. So that is what I have written, BN plus ND, but BN is equal to ND, therefore BD 2 times BN. So sin I can be written as BM upon what? 2 times BN. So we substitute this 5 in 3, so BM is equal to 2 times BN sin I. Therefore continue, triangle BCN now will take. because I want to find out bn ka value. Bn is this one, bn. So I have taken this triangle further, BCN triangle, and I have calculated tan r, and I'm interested in bn. So tan r will be bn upon cn, and cn I know how much. So tan r will be equal to bn upon cn, bn upon t. So therefore bn will be t into tan r, equation number 7, as cn is equal to small t. Therefore substitute 7 in 6, so we can get, therefore in the 6 bm ka value, 2t into tan r into sin I, equation number 7. So tan r can be written as sin r upon cos r, sin r upon cos r into sin I. Okay, multiply and divide by sin r on right hand side, so that we can get in the reduced form of this equation. So we can get, therefore bm is equal to 2t sin r cos upon cos r, multiply by sin r and divide by sin r, multiply by, and mu is equal to we know that sin I upon sin r. So bm 2t into sin r cos r into mu sin r. So this can be written as 2 mu t sin square r upon cos r. Now we got the value of bm, equation number 9, and here the equation number 2 was there. So bc plus cd, substitute in equation 1, so we can get this expression. Therefore, so you can see 2 mu t upon cos r, 2 mu t upon cos r into sin square r. This can be taken common. 1 minus sin square r is cos square r, so this can be written as 2 mu t cos r. But this is not incomplete path difference. If we add or subtract by lambda by 2, then only it will be complete path difference, because light reflected from denser surface. That's why we add or subtract, then only it will be complete. Hence equation 10 becomes complete path difference. Okay, 2 mu t cos r plus minus lambda by 2. Okay, this is the complete path difference. Now we'll write conditions of maxima and minima. So conditions for maxima or minima, constructive interference or bright point, and lambda. So just substitute here path difference. I am taking plus lambda by 2 and lambda. So 2 mu t cos r becomes this. If you take minus lambda by 2, so we get this. Okay, so anyone you can take, either plus lambda or minus lambda. And other one is for minima. This conditions for minima or destructive interference or dark. 2n plus 1 lambda by 2 for dark or destructive. So substitute it, that plus 2 mu t cos r plus lambda by 2. So finally we get, so this is the condition for minima or destructive interference. Thank you.